Hello everyone. In this video, as we finish off our calculus, I just want to look at a few more trig derivatives, and you'll see some of these derivatives here today. We're also going to incorporate some of our exponential and logarithmic rules here as well. So really it's just a summary of all the rules that we have done, combining them all together to see where we are at. So if we get started here in our first example, we need to be really careful. There's a lot of chain rule stuff going on here. First thing I'm going to do is just a quick reminder. Don't forget that that cubed on the cos is actually saying that the whole trig function, which means all of this, is being cubed. That's important as we start to work on our chain rule here. Our chain rule says we always start by differentiating the outermost function. So this would give us then y prime equals. My outermost function here is, if I cover all this up, is that power function where I have the cubed on the outside. So I'm going to start by bringing the 3 down. We are then left with cos of 4x squared minus 7 all squared. I then move in. My next function is this cosine function. The derivative of a cosine function is negative sine of 4x squared minus 7. And then lastly, with our chain rule, we have to move in again. Now the inner function is this polynomial inside, which gives us then the derivative of that being 8x. If we now try to simplify this a little bit, I'm going to collect all the coefficients together. I have a 3, the negative, and I have the 8x to give me negative 24x. With the cosine here, I am going to just move that squared back in on the cos. It's just a little bit neater way to write that. And then I have the sine function. So we have sine of 4x squared minus 7. So here we have chain rule within chain rule within chain rule, and we just got to be careful as we do that. We always just start with the outermost function, and then we just slowly work our way to the inner function. In the second one, we are combining both trig and logarithmic differentiation here. So we need to remember both sets of rules. Remember that the derivative of a ln function is 1 over the argument. In this case, the argument is that trig function. And then we would multiply that by the derivative of the inside. And the derivative this time of cos then would be negative sine x. Combining those together then would give us negative sine x over cos x. If we want to try to simplify that a little bit, we can use an identity here. Sine over cos is the same as tan. So we end up with negative tan x as our derivative. Here I'm going to do the same thing. I have a trig function inside the logarithmic function. We need to be a little bit careful because at this point we don't necessarily have a rule for secant, but we can always get around this by using our trig identities. Remember that secant is the same as 1 over cos 3x. And then we can actually go ahead and take the derivative from here. So y prime equals derivative of our outer function, the ln function, would say it's 1 over the inside. So 1 over the inside would be cos 3x. Now I need to take the derivative of the inside, and I'm going to think of this here. I'll write it on the side. Instead of thinking of it this way here, I'm going to remember that I could actually just do this here with this, is use an exponent of negative 1. That would allow me then to use my power rule. So my outer function then would be negative 1. I would have cos of 3x to the exponent negative 2. I then move inside and take the derivative of the inner function. The derivative of cos would be then negative sine of 3x, and then I still have to move in one more time. The derivative of 3x is just 3. So we see a lot of chain rule happening here as we do this. If I try and simplify here a little bit, I'm going to have then the negative and the negative will subtract out. So my numerator here, I will have a 3, I have a cos 3x, I have a sine 3x, and this will all be over. If I flip this over, a cos of 3x squared. We can do a little bit of simplifying. Cos 3x and cos 3x. One of them will divide out from the denominator, so that we have 3 sine 3x all over cos 3x. And then like we did in our last example, I can actually say here I have sine over cos. The argument is the same for both of them. So this is the same as 3 tan 3x. If we keep going, I'm just going to flip the page here. We can also now do some implicit differentiation with this. We need to be careful. Again, on this side, we would have to use our product rule. So the derivative of the first function would be 2 times our second function, cos 2y, plus our first function, 2x, times the derivative of our second function. That would give us negative sine 2y. Using chain rule, the derivative of the inside, 2 multiplied by dy by dx. On the right hand side then, we would have 2y dy by dx. I'm just going to clean up here a little bit. 2 cos 2y. This whole piece here then becomes minus 4x sine 2y dy by dx, and equals 2y dy by dx. Collecting all our dy by dx's together on the same side will give us then 2 cos 2y, and on this side we will get then 2y dy by dx plus 4x sine 2y dy by dx. If we factor that dy by dx out, oops, not equals, dy by dx, we have then 2y plus 4x sine of 2y. Lastly, we can divide that out so that dy by dx is equal to 2 cos 2y all over 2y plus 4x sine 2y. And then our last step, this will actually simplify. We have 3 separate terms here, and from all terms we can divide by 2. So I'm going to divide 2 out of all of these terms, and that will lastly leave us then with cos 2y all over y plus 2x sine 2y equals dy by dx. And then our last example takes us back to where we were even from our first unit. The whole idea here is that reminder that taking the derivative, we can get the slope of the tangent. If I can find the slope of the tangent, then I can also use that to find the equation of a tangent line. So in this case, we are trying to find the equation of the tangent to this curve here. If you want, plug it into Desmos, take a look. What does that look like? And we're trying to find the slope of the tangent at x equals pi over 2. Notice that as I've written this, that these are in radian measure. So when you're going to do these calculations on your calculator, please make sure that you are in radians to do that. So first step then, we want to take our derivative. So step 1, we will say then y prime is equal to, again we're using our product here rule here, so derivative of the first is 1 multiplied by the second function plus our first function being multiplied by the derivative of the second function, which would be negative sine of 2x times 2. And if we want to clean that up a little bit, we can say then we have cos of 2x minus 2x sine 2x. Step 2, we're looking at then at the point when x is pi over 2, we would have then y prime is equal to the cos of 2 times pi over 2. Be careful as we write this, that this is all our angle here. Minus 2 times pi over 2 times sine of 2 times pi over 2. If we simplify a little bit, this here then will become the cos of pi minus pi times the sine of pi. This is where you can use your calculator if you need to or have to, or if you remember some of our exact trig ratios from advanced functions, we would know then that the cos of pi is -1 minus pi times the sine of pi, which is 0. Remember, you can get those easily if you think of those two trig functions, right? Cosine looking something like this here. There's our pi value at -1, and our sine function looking something like this here. And when x is pi, our y value is 0. So this turns into then slope being -1. Step 3 then, we would then sub in what we know. We know that we have our slope here, which is -1, and we have x and y. We know x is pi over 2. We should actually take a second and go back here. When x is pi over 2, we figured out the derivative, but we should also figure out our y value. So y is equal to pi over 2 cos of 2 times pi over 2, pi over 2 times cos of pi, pi over 2 times -1, which means we have a y value of -pi over 2. So when x is pi over 2, y is -pi over 2 as well. If we sub that into y equals mx plus b, we have our y value, -pi over 2 equals m, -1 times x, which is pi over 2, plus b means -pi over 2 equals -pi over 2 plus b. If I add pi over 2, we end up with 0 is equal to b. Therefore, in this case, the equation is y equals our slope, -1, x plus b, and b is just 0. So there is the equation of the tangent to this curve when x is pi over 2. Again, I'll assign some practice questions. Don't forget, I've already posted some extra review if you have time or wish to review. And this wraps up all of our calculus section. Have a good day, guys.